Hi everyone, I'm Hanuma Maddali from the University of Maryland. In this presentation, I'll be talking about our findings on context that is important to capture when reconstructing meaningful physical spaces for remote instruction and connecting in extended reality. The technology used to reconstruct physical spaces as virtual 3D models has become very powerful, even just in the past few years. It's also being integrated into consumer devices rapidly. These tools can create a reasonably accurate 3D model of an object or area from just a short video or a few dozen photos from different angles. So this is becoming a very exciting time for the HCI community to study remote collaboration using 3D reconstruction of objects, areas, and people. There's already an active body of work on collaboration with reconstruction for professional use cases. Some examples include using virtual replicas for remote expert guidance when handling industrial equipment. When we evaluate the user experience with these reconstructions, we need to think about the context they're capturing. And this includes the sensory and social affordances and interaction that they enable for users of XR in order to effectively accomplish a remote task or provide a fulfilling social experience. We've noted 2 points from past work. The first is the prioritization of sensory context, for example, creating realistic looking models or providing comparable tactile feedback. This is understandable since they can have an impact on task efficiency, especially for professional use cases. The second point is the lack of structured user-centered approach to identify objects and the surrounding contexts that need to be represented in XR. Some systems prioritize reconstructing, for example, hands during surgical procedures. Many are human reconstruction focused, and a few reconstruct the entire visual space's context. We're starting to see glimpses of more remote collaboration tools and experiences involving reconstructions for more casual XR users in informal settings. But right now, the need is to go beyond capturing sensory context and develop an understanding of social context for these reconstructions. For example, how can users better represent personally meaningful objects and spaces in XR? How can these reconstructions enable what we call connecting interactions? One example is enabling a remote pair of gardeners to experience each other's backyards remotely using XR and connecting over a mutual love for nature. Another example involves intergenerational learning experiences, where an older experienced gardener is able to guide a younger novice to an understanding of their garden space. We draw on examples like this and our past findings for remote learning using XR in the garden for this work. Gardening provides a great informal intergenerational activity setting to understand the social context for reconstruction of physical space. It is also, I should say, our idealistic attempt at visualizing what a future remote XR use case might look like for a meaningful everyday social activity. We are trying to answer 2 research questions. The first is to identify important contexts that can influence informal XR experiences with reconstructions of real activity spaces and objects. Within this, we ask what context is important for remote learning experiences and connecting interactions, and what context is important for users when sharing these reconstructions. The second question is to identify design considerations for XR to support goals of an informal intergenerational group interacting with these reconstructions. We recruited 18 participants aged 13 and above as groups of relatives, neighbors, friends, or colleagues who were familiar with each other. Within the groups, we also had varying levels of expertise, and each group also involved people from different age groups with different intergenerational motivations for gardening. In a pre-study session, we asked participants to select a few functional or decorative areas or objects in their garden that could be meaningful or interesting for their partners to learn about. We then sampled photos from short video clips shot by the participants to create 3D models of the areas using photogrammetry. For the main 90-minute study session, participants first do a walkthrough of the garden and the areas it's selected over video chat. This acts as a reference for a shared remote garden experience. They then evaluate their experience using a remote XR prototype that we built for 2 learning-based scenarios from our past work. Participants on-site use a mobile or tablet as an AR device to overlay the reconstructed model on the garden and see a basic avatar of their partners. The remote participants are provided with the VR headset to do the same. In the first scenario, an expert will move a virtual sun across a reconstructed garden plot to help the novice visualize sunlight distribution at different times of the day. In the second scenario, an expert can simulate rain on the model of the novice's plot and describe how to use the slope and flow of water when planning the garden. In our interviews, we ask how participants feel working with reconstructions in XR, what features or interactions of the model would be useful for them in a teaching setting, and if there are objects, areas in the garden that they would like to capture as 3D models to share with their friends or family, and what affordances and interactions would be important for those shared models. For all these questions, we ask participants to think about comparing with conventional 2D media, like in the remote garden walkthrough. We collected observation notes and recordings from video chat, interviews, and from mobile and VR device usage. We performed a thematic analysis of this data following Braun and Clark's suggested approach. In our first research question, our participants described exploring relations at different scales in the garden as part of instruction. Our sessions had involved reconstructing models ranging from small flower beds to large terrace slopes. And this could be useful to describe the process of integrating a large community garden. Participants saw these kinds of reconstructions of systems with interconnected parts spread over a large area as more suitable to experience and learn about in XR. At this scale, reconstructions in XR allowed participants to reflect on, for example, interactions with terrain and the local environment, like animals. But participants also felt that video chat had an advantage for minute features since it forced the novice and the expert to focus on a smaller, high-quality field of view. The difference in quality might have been due to our models being captured from a slight distance. It is worth considering if a more collaborative and hands-on reconstruction method might encourage reflection on other contexts like tactile features and why they're important to reconstruct. We also find that when participants experience reconstructions via the prototype, they were able to apply the real-world experience in the rain simulation scenario. But for the sun scenario, participants like P6 felt that models did not capture enough of the neighborhood to be able to realistically give an idea of behavior with sunlight. For example, shadows being cast by surrounding trees. The implication is that certain contexts can't be captured by the model, and the user can become more aware of this if they can define a meaningful neighborhood for the object to be reconstructed. Our next research question asks about contexts that reconstruction should capture for social connecting interactions. We came across a diverse range of objects that participants want to reconstruct in the pre-study session and after experiencing our prototype. Many of these objects connected the participants with memories of their loved ones. We find that being able to create models for participants like P2 that enabled experiencing the object in XR as if it was at a particular time would be personally meaningful. For example, when a tree is in full bloom, and also adding some narrative context that would help their partner understand the importance that the model held for them. In our paper, we connect these findings to the idea of creating 3D mementos in social topographies in XR. These could augment how we preserve family memories and heritage on a more personal level as part of casual XR. And research question 1C asks about context important when sharing the reconstructed object with others. Here we find that master gardeners among our participants were motivated to publicly share reconstruction for educational purposes. And there were also contrasting views on whether participants felt anonymizing content baked into the model, such as house numbers, was necessary. Participants also felt like they might want to ask permission if they're creating a model from a community space. In our paper, we connected these findings to the literature on privacy of reconstructed spaces. And finally, for research question 2, we identified considerations for intergenerational experiences based on how our prototypes are perceived and used by our intergenerational groups. Find that there are contrasting views on the utility of 3D models in XR versus experiencing nature on site. Many participants are interested in how reconstruction could be used for sharing of knowledge, such as passing on old traditional ways or educating older generations on modern sustainability techniques. Others were interested in being able to listen to family stories using the reconstructions. We find this how the older participants felt the technology itself might be more appealing to their younger study partner or more tech familiar people. However, even in these groups, there was a positive dynamic between the partners that helped them push each other to explore the prototype and discuss what they might want to reconstruct for their own views and why. We also discussed how our approach of collecting videos might have limited the quality of reconstruction in final experience with the prototype. Please read our paper for more details or contact me on